Hello, class. This lesson is Chapter 6-7, Problem Solving with Equations. In this lesson, I will be introducing to you two new types of problems, one with ranges and one called using the distributive property. In the assignment, you will be utilizing both of these methods as well as the methods that we have used in the past, working backwards, using a table, possibly even setting up equations. But in the first part of this lesson, we're going to learn to utilize equations to find ranges. In these types of problems, they are going to be giving you two types of percents, or two different percents. For example, in this one, they say that runners try to keep their heart rates between 60% and 75% of their maximum heart rate when training. You've probably seen the pictures or even know people who wear kind of like a Fitbit or wear kind of a monitor. They are working towards a maximum heart rate, and they want to stay between 60% and 75% of that. The maximum heart rate is individual for each runner. In this particular instance, the maximum heart rate is going to be 205 beats per minute. If this runner is keeping track of the heartbeat rate, what heart rate should he train? So the first part is to find the 60%. I have a tendency to find the lower rate first. And this is done by equation, which remember is percent as a decimal or fraction times a whole equals a part. What we're really finding here is 60% of 205. As a decimal, that's going to be 0.6. 205 equals n. Running that through the calculator, we're going to find 123 beats. We cannot use any decimals, obviously, because your heart can't beat part of a beat. It's either a beat or not a beat. Then you have the higher rate, which is going to be the 75% of the 205. You could use the fraction here, but I think you're probably going to be just as wise using the calculator and using the decimal of 0.75 times 205 equals the part which we do not know. Now, this one comes out to be 153.75. So we're going to round that up to 154 beats. Since the 153.75, the 0.75 is over 1/2. So this is the only example I have of using ranges, since it should be fairly self-explanatory for you. The next type is a little bit tougher. In this case, we're going to be using the distributive property that we used way back in chapter like 1 or 2. Okay? Tickets are costing $8 for adults and $5 for children. They took in a total of $1,336 and they sold 200 tickets. How many of each ticket were sold? So if we allow N to be the adult tickets, that would mean that the children's tickets would be the 200 total tickets minus the number of adult tickets, or 200 minus n. Now we're going to be setting up an equation that's going to remind you a little bit of the ratio, because it's really 8 for an adult per $5 for a child. So we're going to take $8 times the number of adult tickets plus $5 times the number of children's tickets, which is 200 minus n. And our total is going to be 1,336. The 8n can be copied down. Now we're going to have to use that distributive property of taking 5 times 200, which would be 1,000, minus, then we have to take the 5 times the n, 5n, which equals 1,336. Now going back to the skills we had in chapter 2, we are going to simplify like terms. 8n minus 5n, we're going to group those like terms first. This is usually an optional step. We usually do this mentally. Plus our 1,000 is going to equal 1336. Now I can simplify this because 8n minus 5n is 3n, plus my 1,000 is 1,336. At this point, you have a two-step equation, and you've been solving these for a while. So we're going to take 3n plus 1,000 minus 1,000 equals 1336 minus 1,000. 3n is going to equal 336. One-step equation left. To divide by 3, n is going to be 112. And that is the adult tickets, because if you remember back up here, n is the adult tickets. But it does say to find the number of each type of ticket. So I'm going to take 200 minus n, which would be 200 minus 112, and find that there are 88 children tickets. Now the 200 minus n comes back from over here where I said, okay, the children's tickets are going to be the total number of tickets minus the adult tickets. Let's try another one like that. This was another very common example. A librarian spent $174.65 on 15 books. So the total number of books is 15. Some of the books cost $12.99. The rest are going to cost $8.95. How many books did the librarian buy at each price? Okay? Expensive books is going to be n. Less expensive is going to be 15 minus n. We'll put arrows here so you know what it is. So the less expensive books are 15 minus n. The expensive books taken away from total of 15. Now I need to set up the equation. So you're going to have $12.99 n. That would be the money for the expensive books, plus $8.95 times the 15 minus n is going to be our total of $174.65. The distribution property has to be used next. So $8.95 times 15 is going to be $134.25. Get your calculator out, do it. Pause if you have to. Get your calculator out and take 8.95 times 15. Now remember, you have to distribute to the 15, but then you also have to distribute over the n. So it's going to be 895 n equals 174.65. Now, stop and think. What are we going to do? We have some like terms, the 12.99n and the 8.95n. We're going to subtract that and get 4.04n plus the 134.25 to equal the 174.65. Now you're down to that two-step equation that you've been dealing with for a while in your math journey. So we're going to subtract and we will be at 4.04n equals $40.40. Now we divide, and we find that n is 10 books. Now those are the expensive ones, so that's the ones that are at $12.99. But we want to know how many of each. So we're going to have to take 15 minus n, which would be 15 minus 10, which would equal 5 books at $8.95. And that's the conclusion of Lesson 6-7. When you are finished with the lesson, please reply to me with, "Remember the Alamo." Catch you later.